Hello dear students, welcome to Pen and Paper Chemistry, and we will continue with the topic of aromatic aldehydes and ketones. And what you are expected to do is to keep your notebook and to keep your pen handy so that you can take down notes. In the previous video, we have already covered the nomenclature of aldehydes and ketones. So, request you to watch video 1 and then continue with video 2, which is this one. Starting with the preparation of aromatic aldehydes and ketones, what you will do is you have this flow chart which I shared in the first video. If you missed that, you can take a screenshot of the flow chart now and draw it yourself. In fact, I have also shared it on the Google site Pen and Paper Chemistry. So in case you are not able to do it on the screen, you can watch it on that site as well. So let's get started with the preparation. I would encourage you to write the reactions yourself. If you notice, aromatic aldehydes have been prepared from the same compound. You see, the first one is toluene, toluene, toluene. Same compound but in 3 different ways. The first one is called Aldehyde reaction. The second is simply oxidation in the presence of chromic oxide and acetic anhydride. The third is halogenation followed by hydrolysis. So let me start with each reaction step by step. So go and write the reactions. The first one is toluene. What is toluene? C6H5CH3. It is oxidized by chromyl chloride in the presence of CS2 or carbon tetrachloride as a solvent. So what is happening over here is, in this structure, the chromyl chloride CrO2Cl2, what we've done is we've just rearranged it and we've put it as OCrCl2, and the second O combines with the H. Now this is not the mechanism. As I always say, these are only steps to make things easy for you, right? The next step that happens, so you will have over here the hydrogen so I will put over here C, H, H and H, right? This is your CH3. The hydrogen OCrCl2 and then O and then H. Remember, the hydrogen comes here. Then OCrCl2OH, right? This forms a complex, a brown chromium complex. Next step, the O breaks down, so H and OH, H and OH. So ultimately what do I have? I have a benzene ring, CH and then OH and OH. Now do you recall having done this earlier, that this kind of a species wherein there are 2 OH groups attached to the carbon is very, very unstable, because both the oxygens are electronegative. They want to take away the electrons. So what will happen here? Yes, the breaking. So H2O makes an escape, and what are we left with over here is simply C6H5CHO. So ultimately the toluene has got oxidized to benzaldehyde. C6H5CH3 turns to C6H5CHO. Write down the reaction in this specific manner in your notebook. For clarity, you can see it here. The preparation of benzaldehyde by 3 different ways using the same compound, that is toluene. So first is chromyl chloride. We have a brown complex, and then go on to break down the brown complex HOH HOH. You don't need to show the intermediate, and you can directly go on to show the compound form, that is benzaldehyde. We are simply writing it as a skeletal equation, so don't worry about the side products. We can concentrate on organic chemistry, right? Have you written this down? The second method of preparation is oxidation with chromic oxide in the presence of acetic anhydride. Notice the temperature conditions, 0 to 5 degrees Celsius. You get an addition product here as well, CO. Is it addition? No, it's substitution, because the single bond remains as a single bond. So OCOCH3, OCOCH3, followed by hydrolysis. Apply the same logic over here, HOH and HOH, right? I cannot have two OH groups. Ultimately, the product over here is again benzaldehyde. So look at the reaction that is shown in the flow chart, and it becomes pretty simple to write down the reaction. Go ahead. You can show the breaking down of the compound and write the formation of the product, that is, as I said, benzaldehyde, C6H5CHO. Now look at the third method of preparation from toluene. If you see over here, we are using a halogen and we are carrying out this reaction in the presence of light. Correct. So what does this light and halogen remind you of? Do you remember the reaction of alkanes, the first reaction that you do? Replacement of hydrogen by the halogen in the presence of light, diffused light, to give us a halogen substituted product. So that means when I am carrying out this reaction in the presence of light, there will be no substitution in the ring. Instead, it is the side chain which undergoes a replacement or substitution reaction. So we have the product C6H5CHCl2. You can name this compound according to the IUPAC system to give yourself a practice, right? And then finally comes the hydrolysis. That means treatment with water at 373 Kelvin. So again, in hydrolysis, the basic reaction, again, as I say, not the mechanism but the reaction. So the halogen gets replaced by two OH groups. Two OH groups cannot stay together. They leave the compound forming water, and what are we left with? Yes, our favorite benzaldehyde for this particular topic. So would you like to write the reaction yourself? Remember, what kind of substitution reaction is this? Is this electrophilic substitution? Okay, let me give you the options. Tick the correct option. Is it? I'm talking about the third reaction. I am talking about this reaction. Is it electrophilic substitution? Is it nucleophilic substitution? Or it would be free radical substitution? Of course, we can do the mechanism, but just based on the knowledge that you have acquired so far, what do you think the reaction mechanism would be? Yes, of course, it would be free radical substitution. So go ahead, form the products. Again, we will have C6H5CHO as the final product. Right? So this way we prepared benzaldehyde from toluene, but by three different methods. Do you also notice that I have kept the flowchart on the side of this slide for quick reference? That's the reason I told you to keep the flowchart ready for the next video as well. Now, preparation of aromatic aldehydes from benzene simply involves electrophilic substitution reactions, and you look at the similarity of the names Gataman-Koch reaction and Gataman aldehyde synthesis. So If you see over here, we start the starting compound is benzene, of course, the organic compound, it's just the reagent. So we've got CO, that is carbon monoxide, plus HCl, which is actually going to give me formyl chloride in the presence of anhydrous AlCl3 or CuCl and anhydrous AlCl3. What does this remind you of? Remember something that we've been talking about in aromatic compounds? Yes, of course, Friedel-Crafts reaction involving electrophilic substitution. So electrophilic substitution, positive, negative, and our benzene ring is electron rich. So which part of this molecule is going to attack the benzene ring? Yes, of course, the CHO. So what we are going to do is we are going to keep it simple and we will write the products of the reaction over here. That is, we get Benzaldehyde. In Gataman aldehyde synthesis, what we've got is we are taking HC triple bond N, that is hydrogen cyanide, and HCl. Of course, they will first form an addition product and then we carry out the reaction with benzene. Again, anhydrous AlCl3, again a modified Friedel-Crafts reaction. Yes, and so here the first step is treatment with anhydrous AlCl3. And this gives us a substituted product which I have drawn in the flow chart as well, but I would suggest that you may actually leave it, just go ahead and draw the final product instead of showing the steps over here. Even that would be equally fine. So we make over here, so this we've got NHCl, so basically an substitution product over here, followed by hydrolysis, our favorite step, and we break it down and we have H over here and H2 here. So that gives us the final product, that is CHO, that is Benzaldehyde. Clear? Yes, you don't need to go into the details of this step. It is fine at this point of time. Rosenman reaction. What does this remind you of? Do you recall having done this reaction in aliphatic aldehydes as well? Do you remember having spoken about this reaction? Go ahead, look at your flow chart and write the reaction. It's all clear in the flow chart, and that is how you will learn to be independent as well. And that's the sole motive of this channel, to make it so interesting for you that you'll start learning things on your own rather than depending on others. Written? So here we go. It is reduction of benzoyl chloride in the presence of palladium and barium sulfate to give us benzaldehyde. Go on to the next one. See, again I have brought in the flow chart to our rescue. At any point of time you want to refer to the reaction, look at the flow chart and there you go. Benzonitrile C6H5CN. So what are we going to do? We have to convert it into C6H5CHO. The method is called as Stephen reaction, where we carry out reduction followed by hydrolysis. And how do we carry out that reduction? Using SnCl2 and HCl. So what will happen? Yes, you're going to do the details of this particular reaction under the topic of nitrogen derivatives as well for organic compounds. In the meantime, let me write the reaction. Oh, you've already written. That's wonderful, because here what we are doing is C6H5 C triple bond N, you reduce it HH, and because it is basic in nature, the HCl becomes attached to it and you have a reduced CH double bond NH HCl. It's a reduction product followed by, of course, what are you going to do? What are we left with? Yes, hydrolysis. Break it down and you have O and OH, and we have the product C6H5CHO. Right? Easy. One more to go before we close this lesson. And this is nothing but the preparation of ketones by our favorite FC reaction, that is the Friedel-Crafts reaction. Electrophilic aromatic substitution. Now that should give you a good hint as to what could be the reagents for this reaction. Yes, of course, our favorite anhydrous AlCl3 of course is there. And what should I treat benzene with in order to replace it? Let's suppose I want to replace it by COCH3 group. Remember here that you should not write it as CH3CO. That would be wrong. Why would it be wrong? Let me write the expanded structure CH3 and then C and then double bond O. Does that make sense? You see over here, our carbon here is showing 5 bonds, whereas this carbon is hungry. So what do? We need to flip this around so that it is the C double bond O which becomes attached to the benzene ring. With the result, all things fall into place because our carbon over here is going to form a bond with the C double bond O and all are happy, right? See the difference in how you are going to write the formula. This is a very, very common mistake that we do as beginners. That is why I am pointing it out. Coming back to the preparation of ketones, so I want to replace it by COCH3, electrophilic substitution, CH3COCl, right? And what is this reaction specifically known as? It's Friedel-Crafts acylation. Yes, now you can relate to the mechanisms as well that we had done as the basic concepts of organic chemistry. There are separate videos to explain all the mechanisms, and these I have posted on the channel, and the notes corresponding to that are also there on the site. I'm trying to post all flowcharts onto the Google site Pen and Paper Chemistry. I'm trying my best. Please excuse if I've missed out some. As well as the mechanisms, as I was mentioning to you just now, there's a separate playlist on the channel based on mechanisms and the fundamental concepts of organic chemistry. In the next video, we are going to take up the properties of aldehydes and ketones, and there again I will give you a nice flow chart. So please keep your pen and paper ready and continue to enjoy learning chemistry. Take care. See you soon.